It's called a Colligan. This heat and mass transfer HW4. To start off with the first problem, you want to find the base temperature of a pipe that has a flange on it that acts as a fin to disperse heat. In order to solve for the base temperature, you need to set the heat transfer rate of the pipe equal to the heat transfer rate of the flange. And then from there, you're going to need to find this squiggle in order to find the efficiency of the pipe. So you find all the squiggle properties based off the properties of the flange, and once you have the squiggle, you find the efficiency, and then once you have the efficiency, you have all the variables you need to solve for the temperature base. And then next problem, you are given just a standard little fin that has a certain temperature at the base, and you're going to make a few assumptions. First, I'd say 1D conduction, constant heat transfer coefficient, and then there's no radiation. And then from there, you're going to use all these equations: the equation for the long fin, adiabatic tip, specified temperature, and convection at tip, in order to create a temperature profile and find the heat transfer amount. And then from there, you can put all those equations in here and then into Excel, and then you can actually graph the temperature profile. All these equations are going to come from 3-64 to 3-71 in the textbook. And then for the final problem, you have a circuit board, and I want you to first find the temperature of the inside and outside of the circuit board. So that's basically all you gotta do is find the resistance through the board and the resistance at the surface between the air interface and the board. And so you can find the temperature of the surface that's exposed to the air, and then you find the temperature of the surface that's on the other side. And then for the next problem, what you're gonna have to do is you're gonna have a board that's attached with epoxy, that same board from above, and that's attached with epoxy to an aluminum that has fins on it. And I want you to find the temperature of the board and the temperature of the inside and outside of the temperature of the aluminum board, and then also the temperature inside and outside of the circuit board. To do this problem, you're first going to need to find the efficiency of the board, and that's based off the efficiency formula for a rectangular board, which is a hyperbolic tangent of ml divided by ml. And then from there, you need to find the heat transfer rate of aluminum with the fins, and the heat transfer of the area of the aluminum without the fins, and then you add those together, and that's going to be your heat transfer total of the aluminum. And you can solve that system of equations or find the temperature of the base of the aluminum. And then finally, I want you to find the temperature of the circuit board on the inside and outside. To do that, you need to find the resistance of the aluminum and the resistance of epoxy, and then you can find the temperature of the outside, the part that's not touching the epoxy of the board, by summing up all the resistances of the epoxy, the aluminum, and the circuit board, and that will give you the heat transfer on the outside. And then the part touching the epoxy, all you have to do is the temperature of the side on the outside divided by the resistance of the board to find the temperature touching the epoxy. Thank you.